Okay, so this is Nick Baciu, math teacher in the state of Maine, and I'm trying to help my students and whoever else is interested to improve on math. Math is definitely not easy, and one of the most difficult parts is algebra and geometry, but there is an issue here: equations, mostly linear, and they are used in algebra but also in geometry. There are problems in geometry, many problems, where you can, in order to solve them, you have to apply to use equations and to write the solving problem, to solve the problem, translating the story there about different shapes in geometry into an equation. So that's why linear equations are important, and also the other two are quadratic and exponential. So I'm going to work on this video several situations about linear equations and how to solve them. So the most important part in this solving is to isolate or separate the unknown variable. It can be x or any letter. Usually it's x. So I can say isolate x. What that means is to have x equals and something, some numbers, a number actually, to find the value of x. How we can do that? I would try it right here, but it's very general speaking. We have to subtract b in this case. We have to get rid of b, the first thing. If it's an addition here, we have to use the inverse. So we use the inverse operations, starting with plus or minus. In this case we have plus, we use the inverse minus. We subtract b. But if we subtract b in this side, one of the algebra rules and math rules is that the equality symbol must be kept in good shape. So that means if we subtract something here, we have to subtract something, the same thing here. So now we'll have ax and b minus b, that's 0. You can say plus 0 if you want. And here we have 0 minus b, which means minus b. And now we can disregard this. We have ax equals minus b. How we can get rid of a to isolate x completely, x on this side? Here ax means a multiplication. So we have to use the inverse operation, which means to divide by a. And if we divide here by a, we have to divide in the same way on the other side of the equality, the same number a. Here a over a is actually 1, so we can disregard that. So we only have x left here. And on this side we have minus b over a. That's the general rule. So when you have a form of this equation, you should memorize maybe that x is minus b over a. But let's solve a quick problem. Let's say we have 3x plus 5 equals 0. How much would be x? Following this formula, that would be x equals b is 5. So that would be minus 5b over a, and a is, in this case, is 3. So that will be minus 5 over 3. But maybe it's hard to remember this formula, so let's try to do it, do some numerical example. So let's say we have 10x plus 5 equals 0, let's say. How much would that be? First of all, we have to get rid of this 5. So what we need here is to isolate x, to have x by itself on the left or maybe on the right, and on the other side a number. How we do that? We have to get rid of what we have on this side, minus plus 5. We use minus. If this was minus, we would use plus. And actually, let's try to do it right now. So that will be 10x minus 5, and here we'll have to add 5. So get rid of that. Minus 5 plus 5, it will be 0. If we add 5 here, we have to add 5 here also. So that means 10x minus 5 and plus 5, that's 0. We can disregard that. And here 0 plus 5 is 5. Now, in order to isolate x further, we have to get rid of this 10. So this is a multiplication. So we have to do a inverse operation, division. We divide by 10. And here also divide by 10. 10 over 10, that will be 1, and that means x is finally separated. It's by itself. And here we have 5 over 10. And we can reduce this fraction dividing by the common factor 5, and that will be 1 over 2. So that's the result. That's one type of a problem, of a equation. That's the simpler type. The more difficult type would be something like this. Let's say 1 minus 3x equals, let's say, 4 plus 2x. Maybe, yeah, probably it's okay. Let's see how we do that. We have to move the x to the left and the numbers to the right and isolate x to the... How can we do that? How can we move the x to the left? We have to get rid of x here by subtracting it. 2x here, and also subtract 2x here. This way we got rid of x, because 2x minus x is 0, so we don't have x's anymore. And here we'll have 1 minus 3x minus 2x, that will be minus 5x, equals 4. Okay, plus 0, whatever. Now we have to get rid of this 1. How can we do that? By subtracting it, because this is a positive one. So we subtract here 1 also. So that will be 1 minus 1 is 0. Minus 5x equals 4 minus 1 is 3. Now we have minus 5x, because this is how it is here, equals 3. What else we have to do to get x by itself? We have a multiplication of minus 5 times x normally. That's what it looks here like. So we have to divide by minus 5 on both sides, minus 5. In this case, minus 5 over minus 5 goes away, and x will be 3 over minus 5. You can move the minus in front, that will be 3 over 5. So that's the result here. So that's a bit more complex. Why? Because we had x on both sides, we had to move this x here. As you can, I'm not gonna say anything yet, but still it's good to notice that what we do here when we see 4 plus 2x, we subtracted 2x, we use the inverse operation of the plus, we use the minus. And we did the same thing here. In fact, we can actually say that we move this 2x with a change sign on the other side instead of just... But for now we can keep doing this, it's more probably easier to understand. Okay, let's try the third type of a problem like this, and this involves fractions. Let's say we have 3x over 4 equals 1 over 3, let's say. Okay, how do we solve that? How can we make sure x is separated from the other numbers? First of all, I would multiply here with, you can write this as 3 over 4 times x, basically. That's what it happens here. 3 times x over 4 is the same thing like 3 over 4 times x equals 1 over 3. One trick here is to multiply on both sides with the reciprocal of this one, 4 over 3. Why? Because the reciprocal of a fraction, when you multiply them, you get an 1 here. 4 times 3 is 12, 3 times 4 is 12, so it's 12 over 12, that will become 1. But I have to multiply here the same way with 4 over 3. So let's see what happens. This goes away, becomes 1. We have only x left here. Here we have a multiplication of two fractions. 1 times 4 is 4, and here 3 times 3 is 9. So the result is 4 over 9. Another way to look at this is what they call cross multiplication. We can multiply this and this, like this. I'm going to use maybe a different color. Cross multiplication. And this with this. And it becomes like a linear relationship. So 3x times 3, I'm going to do it here, equals 4 times 1, 4 times 1. And that means 3 times 3 is 9x equals 4. Now, in order to get rid of 9, we have to divide by 9 on both sides. So this will become just simply x equals 4 over 9. So we get the same result using what they called cross multiplication. Before, what we did was to multiply with the reciprocal of this fraction 3 over 4 on both sides. So we got the same thing. But cross multiplication probably it's easier. Let's try another one, and that's it. And this is a bit more complicated. Okay, we'll have also fractions, and let's say something like 3x minus 4 over 7 equals, let's say, 2. How to solve this? We can consider a cross multiplication thinking that this 2 is actually 2 over 1, a fraction like that. When you have an equality of two fractions, we can multiply this with this and equals this times this. Let's do that. So that's 3x minus 4 times 1. Let me write it down like that, times 1, even if it usually. So this is, and here is 7 times 2 is 14. So now we have 3x minus 4 equals 14. We have to get rid of the numbers here to let x by itself. So the first thing, we add 4. That will annihilate this minus 4. We add 4 on both sides, of course. And here it will have 3x, and this will be 0. And here we have 14 plus 4 is 18. Now we have to divide by 3 to get rid of this 3. Because it's 3 times x, we use the inverse operation, divide by 3 on both sides. So that will be 3 over 3 is 1. So that lets the x by itself on this side. X equals 18 over 3, which is 6. So that's the result of this equation. This is the types of linear equations which we can solve. And I'm working on a certain program which will be a free bonus to get a lot of equations randomly, to create random equations just for practicing. And whoever wants it will be stay tuned and follow our website, and you'll get that for free. Thanks for watching.